Hi, my name is Taylor Anderson. I'm a senior product manager with Elastic Beanstalk, and joining me today is Sefer Sami, senior solutions architect for Microsoft Platform. And today we're going to be talking about migrating ASP.NET applications to Elastic Beanstalk. Okay, so here's our agenda. We're going to start off by reviewing some key Elastic Beanstalk concepts that we'll need as we go through our two migration demos today. And for our first migration demo, we're going to show you how to migrate an ASP.NET website using the new Windows Web Application Migration Assistant. And then for our second migration demo, we'll show you how to migrate an ASP.NET website using the AWS Toolkit for Visual Studio. Okay, so let's first review some key Elastic Beanstalk concepts. When it comes to migrating a web application to the cloud, we get a lot of questions from customers beyond just getting it up and running in the cloud. And some of those questions include, if I'm migrating a web application, how do I design for high availability and ensure that my application can scale dynamically? And how do I deploy new application versions safely, keep my runtime and operating system updated and patched? And how do I monitor application health? Well, AWS provides customers with lots of different options for building their web services in the cloud, and these can be thought of as building blocks. And we've got all kinds of building blocks for compute, storage, networking, database, and management. And so customers can build pretty much anything with these different kinds of building blocks. But for customers that are migrating to the cloud, they're interested in how they can do so quickly and efficiently without necessarily having to master a large number of different services. And so common question is, hey, is there one service that I can use to run my migrated web applications? And the answer, of course, is yes. And that's by using AWS Elastic Beanstalk. So by using Elastic Beanstalk, you can work with just one service that automatically handles infrastructure provisioning, auto-scaling configurations, network and security configurations, load balancing configurations, your OS and runtime updates, application deployments, health monitoring, as well as your application analysis and debugging tools. And Elastic Beanstalk provides all these capabilities at no additional cost. So what Elastic Beanstalk does is it provisions the underlying resources to run your application, and then you're billed for the usage of those resources, such as EC2 instances or load balancers. So a couple other things that are notable that you can do with Elastic Beanstalk. You can modernize an application using multi-container Docker environments that are available in Elastic Beanstalk. You can serve and scale a machine learning model. You can integrate and use a CI/CD pipeline to automatically push application updates to your Elastic Beanstalk environment. You can also run blue-green deployments. Now, today we're going to be talking about ASP.NET web applications, and we're going to be talking about running Windows Server environments in the cloud in Elastic Beanstalk. But Elastic Beanstalk supports many more environments beyond just Windows Server and ASP.NET, and these include environments such as PHP, Java, Ruby, Go, Node.js, Python, as well as Docker environments. So whatever your preferred runtime is, your preferred language of choice for developing web applications, there's a matching Elastic Beanstalk platform that you can run on. So when it comes to migrating a web application to Elastic Beanstalk, and for today's discussion, specifically ASP.NET web applications, there are two migration paths. And the first path is to migrate a website directly from a host virtual machine that it's currently running on. And so for path one, we're going to see in a demo today how to use the Windows Web Application Migration Assistant, which is a PowerShell script. The other path for migrating a web application to Elastic Beanstalk, if you have access to the source code, is to upload an application bundle. Now, there's different ways to upload your application bundle into Elastic Beanstalk and run it For today, we're going to show you how to do that using the AWS Toolkit for Visual Studio. But there are also other avenues as well for uploading your application bundle and running it in an Elastic Beanstalk environment. These other options include using the Elastic Beanstalk console, the Elastic Beanstalk CLI, the AWS CLI, or a CI/CD toolset. Okay, so let's briefly go through an Elastic Beanstalk workflow for getting your web application up and running in the cloud. And there are 3 core steps here, which include configuration and provisioning, then deployment, and then monitoring and managing. Okay, so when it comes to configuration and provisioning, within Elastic Beanstalk, there's a concept of an application, and an application can be thought of as a container of environments. So in this case here, we have an application called My App, and we have 3 different environments that we're using here. So we have on the left a dev environment, in the middle a staging environment, and then on the right a prod or production environment. And in each one of these environments, we have a different version of our application. So on the far right here in our production environment, we're running V1 of our application on 3 different instances. And then our staging environment, we're running V2 of our application. And then in dev, we're running V3. So in each one of these environments, we can run a different version of our application, as well as run it on a variable number of instances, depending on our workload. So what Elastic Beanstalk does is it orchestrates different resources to create an environment. So what that means is, for example, in our staging environment, Elastic Beanstalk has provisioned EC2 instances. It's created the security groups to control ingress and egress from those instances, set up a load balancer, as well as configured auto-scaling groups. And Elastic Beanstalk also configures Route 53 with a unique domain name that you can configure and route to. And Elastic Beanstalk also allows you to safely deploy your code or your application updates. So when it comes to managing application versions that you're going to be uploading through that second migration path that we talked about, Elastic Beanstalk stores every code version that you upload as its own unique application version, and each version is stored durably in Amazon S3. So this makes it easy to roll back your environment to a previous version. Now, when you deploy an application to an Elastic Beanstalk environment, it's deployed on top of a platform. And so if you look at the diagram on the right, the white elements represent the platform that's provided by Elastic Beanstalk, which includes the operating system, language interpreter, an application server, and an HTTP server. So what Elastic Beanstalk does is it combines all these different elements into a single platform, ensures that they're all working seamlessly together, and then deploys your app on top of it. At the bottom of the stack, we see host, which is your EC2 instance that your application is running on top of. So if you're actively developing an application, you're pushing out new versions regularly, you have several different options with Elastic Beanstalk for your deployments. So if you have multiple instances in your environment, you can deploy a new application version to all of them at once. You can deploy it to them one at a time with a rolling deployment. You can deploy it to them one at a time with additional batch. So additional batch means that you can decide to create additional capacity for your environment so that the original capacity of your environment is preserved as instances are updated with new application versions. We also support immutable and blue-green deployments. Elastic Beanstalk also provides health monitoring. So not only does this include instance level health monitoring, so looking at things like CPU usage, network IO, memory usage, Elastic Beanstalk also provides application level health monitoring as well. And so we're going to be looking at things like HTTP requests. I'm going to be looking at 2, 3, 4, and 500 responses, as well as looking at HTTP latencies And all this is visible in the Elastic Beanstalk console, and then also available for you to consume via AWS CloudWatch, so that if you choose to, you can set alerts and alarms using CloudWatch events. You can log these metrics using CloudWatch logs. And Elastic Beanstalk also offers an integration with AWS X-Ray for easy analyzing and debugging. And this is all available through the AWS Elastic Beanstalk CLI if you want to integrate these monitoring capabilities into your existing workflows. Elastic Beanstalk also supports managed updates, so we mentioned this a bit earlier. What this does is it allows you to automatically update instances in your fleet with operating system security patches, fixes, and minor updates. So to use managed updates, what you do is you would set a time for the weekly update window, and then at that period each week, Elastic Beanstalk will go out and then apply any platform updates to your instances. Here's just a snapshot of some of the events associated with platform updates here. And so now it's time for us to move on to the demonstration section of today's presentation, and I'm going to hand it off to Sefer.
Without further ado, let's see a demo of how you can use Windows Web Application Migration Assistant. As an example, we'll see how an ASP.NET e-commerce web application is migrated to AWS Elastic Beanstalk using 3 easy steps: configure IAM roles and permissions, run PowerShell-based Migration Assistant, and deploy the website to Elastic Beanstalk. The Windows Web Application Migration Assistant is a PowerShell script developed and maintained by AWS as an open source project available in GitHub. You can run this script on your host currently serving web applications, and it assists you to move those applications to AWS Elastic Beanstalk. As mentioned, the Migration Assistant script is available on GitHub, and you're welcome to download and use it, or contribute to it similar to all other open source projects. The script performs a number of steps. First, it scans your host and discovers ASP.NET websites. Then it prompts you to select one of those websites to migrate. It also scans and discovers database connection string configurations within the selected website and allows you to update it to a new endpoint, as it's likely the database also needs to migrate. After that, the Migration Assistant generates an AWS Elastic Beanstalk deployment bundle and stores it on the same host. You can use that deployment bundle for advanced deployment scenarios. However, in most cases, you could simply let the Migration Assistant to carry out the final task of deploying the deployment bundle into Elastic Beanstalk. Elastic Beanstalk already supports MS-deploy packages, therefore making it an easy-to-use target for integration with .NET continuous integration and continuous deployment pipelines, as well as providing a seamless integrated experience for .NET developers who want to directly deploy applications from Microsoft Visual Studio. The Migration Assistant also relies on MS-deploy to create Elastic Beanstalk deployment bundle packages. Now let's go through the steps for setting up the Migration Assistant. First, an IAM user is required. This user needs to have IAM read-only access and AWS Elastic Beanstalk full access policies attached to it. You also need to get the programming keys for this user. Using the programming keys of that IAM user, for example, in this case, the user called migration user, a user profile is created in AWS Tools for PowerShell. This user profile is a way to securely store the IAM user's credentials on the host. Now, let's see how creating that user looks like. So this is the IAM console. I'm adding a new user. I'll call it migration user. And remember to tick programming access and simply select to attach existing policies. As mentioned, there are 2 policies. Elastic Beanstalk full access and I am read-only. Both are attached, and create the user. Now it's showing the programming keys in the console, and all I have to do is to copy the programming keys from here, and then I can use that in AWS PowerShell with this commandlet, set AWS credentials, and the access key and the secret key. And I'm storing it in the migration user profile. That's the profile name here. Optionally, you could also migrate any backend databases that your website might have. Windows Web Application Migration Assistant doesn't migrate databases, but there are a number of other tools and services already available in AWS to assist you with that task. For example, you can use AWS Database Migration Service or Cloud Endure Migration. Finally, to complete preparation and start using the Migration Assistant, download its package from GitHub. From the URL that you can see on the screen, and copy it onto your host where your web applications are currently running. Now let's run the Migration Assistant script and see the steps that it carries out. As you can see, on this server, I have two websites, the default website and another website, which is a e-commerce. So if I browse these in the browser, you can see the first one is the default website, and the other one, the e-commerce application, both hosted currently on localhost. So this is my e-commerce application, completely functional. Now, let's run the script, Migration Assistant script. When we run it, it prompts for the profile, the AWS credentials profile. I create a profile name for the programming keys that I just created in the previous step. Now it's prompting for region, US West 2. Then it scans and discovers two websites and shows them to me. So I'll select website number 1, the e-commerce application that I want to migrate. Now it scans my web application and discovers any connection strings that are included in its configuration. Then it lists those two connection strings that it has discovered and allows me to select which ones of these connection strings I want to update. So I'll select connection string number 0. Now I have the option either to directly enter the new endpoint here or select to manually change the connection string endpoint from a JSON file. I'll select the manual option, and as you can see, it's generated data settings JSON file where the connection string is stored. So I'll just change the endpoint from the existing value to the endpoint that's already available in AWS. And I'll save the JSON file and resume. By pressing enter, I can resume the script's operation. The script starts to generate a deployment bundle for Elastic Beanstalk, and then it prompts me to enter a unique name for the Elastic Beanstalk application environment. I'll select a unique name, 2020-01-02 NOP. And then it also prompts for the EC2 instance type, and then the application stack, which in this case is Windows Server 2016 and IIS version 10. And then it automatically uploads the application bundle into AWS Elastic Beanstalk. This operation takes a few minutes because Elastic Beanstalk has to provision the underlying resources and host my application. After a few minutes, when the operation is completed, I can see this URL generated in the output of the script, which I'll copy and paste in my browser. And there it is. You can see the e-commerce application is up and running inside AWS Elastic Beanstalk. You can check AWS console for Elastic Beanstalk and view migrated application in there as well. This is what it looks like. Currently, I have 3 applications in my Elastic Beanstalk environment in this region. This console also enables you to monitor and manage your applications. As you can see, all applications are shown as green, meaning there are no errors discovered in them and everything is operating without issue. And there are additional applications. And if I open one of these applications, you can see the events. I can navigate to configurations and see the configurations available over there. I can also change any of these, modify them if I want. For example, the environment type currently is a load balanced instance, minimum 1, maximum 4. The instance type, you could easily change it to another EC2 instance type. Availability zones, you could select 1 or more availability zones for placement of the underlying server hosts, scaling triggers, and so forth. And for managing updates, you could select what deployment model you want, what deployment policy you want. Rolling updates, for example, what's the percentage of deployment batch sizes. And for managed updates performed by Elastic Beanstalk, what's the updatable minor patches or the weekly update window, all of those settings are easily configurable from the console. As another example, let's see how we can deploy an application directly from Visual Studio into AWS Elastic Beanstalk. The AWS Toolkit for Visual Studio is the only requirement for using Visual Studio to deploy directly into AWS. The Toolkit is an extension for Microsoft Visual Studio that makes it easier for developers to develop, debug, and deploy .NET applications using Amazon Web Services. Without the AWS Toolkit for Visual Studio, you'll be able to get started faster with the AWS Toolkit for Visual Studio. You'll be able to get started faster and be more productive when building AWS applications. The AWS Toolkit for Visual Studio conveniently includes the AWS SDK for .NET, so you can get started building .NET applications on AWS infrastructure services in Visual Studio, including Amazon S3, EC2, Elastic Beanstalk, DynamoDB, and more than 100 other AWS services.
Let's see how we can deploy a web application into AWS Elastic Beanstalk directly from Visual Studio. I have a web application here, my web application. I'll open it in Visual Studio. As you can see, it's a standard ASP.NET MVC application. I'll run it locally first to see what it looks like. As you can see, it's a simple web application developed using ASP.NET MVC. And I'm now going to deploy this application into AWS Elastic Beanstalk. The first thing that I need is to make sure the AWS Tools for Visual Studio extension is installed. You can get that from Extensions tab, Manage Extensions. Now, in this window, if I search for AWS in Visual Studio Marketplace, AWS Toolkit for Visual Studio 2017 and 2019. If you're using a earlier version of Visual Studio, you can use the toolkit for that version. As you can see, it's already installed and available on my machine here. Once you have installed that extension, if you right-click on your web application, you get this option for Publish to AWS Elastic Beanstalk. The first thing you need is an account profile to use. If you haven't already configured an account profile, you can directly create one here. All you need to do is to provide a profile name, storage location, whether it's shared credential file or .NET encrypted store, or the programming keys, AWS Identity and Access Management programming keys, access key and secret access key, the target AWS account number, and the account type. I've already configured a profile for myself, work account. Since this is the first time I'm deploying this web application into AWS Elastic Beanstalk, the only option I get is create a new application environment. Subsequent deployments will also have an option to redeploy to an existing environment. All right, so I'll hit next. Here I have to provide parameters for AWS Elastic Beanstalk application environment. First, the application name itself. This is an Elastic Beanstalk application. As you remember from the concepts discussed, it's a container where your web application will be hosted. So I'll leave it as my web application environment. Again, an arbitrary name. It's suggesting these three names, dev, test, prod, but I can also choose any other name. Let's just select my web application dev and the URL to host this web application. Let's see if this URL is available. By clicking check availability, the wizard will tell me if this URL is available or I have to use another URL. Okay, the requested URL is available. Everything is fine here. I can go to the next page. Container type. This is the application stack, including operating system base, any application server, in this case IIS. And if I open it, you can see options include Windows Server 2012, running IIS version 8, all the way up to Windows Server 2019, running IIS version 10. So let's select Windows Server Core 2019. And instance type is where you can select your EC2 instance type. And this is where you can define how much resources you to allocate to your application. So I'll select M5 X large. You can select the key pair. And if you want, you can use a custom AMI. That's the Windows base. If you don't want to use the standard Windows Server that comes with AWS Elastic Beanstalk, you can use a custom AMI as well. I'll leave it as blank because I want to use the standard AMI. You can use a non-default VPC. By default, this will deploy your application inside the default VPC in your AWS account. But if you tick this box, you can select your target VPC. And if you uncheck this box, you can deploy your application as a load balanced application, and you can use a load balancer in front of it. I'll just leave it as single instance for now because it's a very simple application, but if I uncheck this, I can select a application load balancer, network load balancer, or classic load balancer. And the relational database, if your application has a backend dependency to a database, here you can select the Amazon RDS database instance that your application has to connect. My application doesn't have a database backend, so I'll just leave it blank. Now, because I selected non-default VPC, here in the screen I get the option to select the VPC where I want to deploy my application. I'll select one of my VPCs, the security group, public web app. Because I selected a single instance, ELB scheme and ELB subnet are not applicable anymore. But if I had selected a load balanced deployment, I could select these options as well. For instance subnet, I can select one of my public subnets, so it will be accessible to the internet. Now the application role, if your application requires permissions to use any of the AWS services, you can select that from this drop-down list. Deployed application permissions. There are some role templates. For example, if your application requires access to S3 buckets, you can provide access here. Or you can also use any of the existing IAM roles that you've defined previously. My application doesn't require any access, so I'll leave it as is. And for role, you can select what role the AWS Elastic Beanstalk has to assume in order to manage your application. By default, it suggests an AWS Elastic Beanstalk service role, and I'll leave it just to that. Next, I will get the option for compile and build. So I'll choose release, build configuration release, application pool runtime. My application is on .NET 4, so I'll leave it as that. And the app path, you can leave it as the default website or change it to another path or a custom path, whatever you would want. You can enable 32-bit applications if your application has to run as a 32-bit application. And if I take this box, it will enable AWS X-ray tracing supports, which is particularly useful for distributed applications and helps you to trace what's going on if an application is not responding or it's slow or it has any problems, throwing errors. It helps you track distributed components of your application. And another box for enhanced health reporting. And that's it. In the next screen, I get the option to review all of my configurations. And there's a checkbox here to generate AWS deploy configuration. So I can select the file path to store all of the configurations that I've so far selected in these screens in this wizard in a file. So next time if I want to deploy another application with similar configurations, I can simply select that configuration file and don't have to go through the whole process again. So if I hit deploy, as you can see, it's building the application and packaging it in a deployment bundle zip file. And it's uploading that into AWS Elastic Beanstalk. And it's initiated to create the application, my web application. Now Visual Studio opens this window for me where I can see all the events and other options for my Elastic Beanstalk application. Environment, as you can see, there are some options here. And in the event tab, I get all the events that are related to my application. So far, it's starting the create environment and going through the process of deployment, which will take some time. In other tabs, I also have access to other capabilities, monitoring, resources, AWS X-Ray, as I mentioned before, for distributed applications, server notifications, container advanced, and logs. And these are CloudWatch logs, which could be very useful, especially if you're debugging something or want to know what's going on once it starts running inside the AWS cloud. Now we'll give it some time until it completely deploys the application into AWS Elastic Beanstalk. All right, now as you can see, environment health has been set to green, environment is healthy. Deployment has completed. You see this URL that's given up here. If I click on that, it will take me to the application as deployed and running inside AWS Elastic Beanstalk. Yep, as you can see, it's the same application, but now it's running inside AWS.
So we saw how we can use AWS Windows Web Application Migration Assistant and Visual Studio, the two tools that are available to migrate applications, ASP.NET applications into AWS Elastic Beanstalk. Hope you enjoyed it. Thank you.